And I say a lot of this is done during the first review of the smart plant. Line should be routed as close as possible to the heater. It's just tin plate. It's not very strong. It's usually got a refractory inside all the plates because of the intense heat we use inside these. So I mean, we try to keep the piping as close as we can to minimise the loads to the equipment. Routing the piping shall not obstruct header boxes, tube pulls, openings, explosion, observation, access doors and peepholes. So we have it on here. You can see these are little openings. This radiant section here, the servo, it's got coils inside here. If the coils do tend to blow, as they do quite frequently, they'll pull the coils out in a long vertical, and they'll just pull it out through this hatch, and they'll just cut it as it comes out. And then they'll just bring it in through the new coils in through these openings in here, and just weld them on the inside. Platform requirements to access to the items such as heater items and piping connections shall be per client's criteria. Usually the heaters I find are kind of standard. I mean, if you go from one unit to another unit, they're kind of very similar. They are customised, but there's not a lot of changes on them. One thing we're going to have to consider in the layout is if you've got a burner box right here. One thing we have to do is the operator has to review the flame. He looks at the colour to see if it's yellow or blue. If it's yellow, it's burning inefficiently. If it's blue, it's working well. But we have piping to the burner here. It could be a natural gas or a fuel gas, and we'll have something like a steam or an air line on there, and that helps them throttle the piping, the valves that are underneath here. So he has to have access to that, and he has like a little port that he can view to check out the flame. And he can then determine by throttling the systems if it's burning efficiently or not. They just burn, I guess, byproducts in here. This is another one which they prefer on the side here. We'll put a platform all around the heater, and we have a view port right here. He won't be able to view it like he is. He'd have to put a face mask on here because the heat will be quite intense. But he's operating the valves and he's looking through this port right here. And we'll put the valves to the side here, but he has to be able to throttle all these valves and look inside that port at the time. And we'll have to consider that during our layout. Typical pump arrangements. What we're looking at is a side entry type pumps. One thing we have to consider on these pumps is a type of impeller. We'll get inside. We'll have to coordinate with our rotating equipment guys. We'll have to leave a certain amount of upstream diameters going into the impeller. If you leave it too short, you get a lot of turbulence inside the piping and just erodes away the impellers. It's not just the straight. Sometimes we do have requirements on here to keep it in line as well. But you can see the space it takes up for consideration. We have to defer from a layout. This is just from a different angle. We also have to consider adjustable type supports. That's basically for alignment on the pumps. We got forged piping. We got cast iron casings. They're very, very weak compared to our piping. And if we put too much force on these nozzles, the casing will crack. And that's just part of our detailed design we get involved in. I think tomorrow, I think you won't be, but you got the stress review. One thing we always tend to be doing at pumps is we have to put flexibility in there. We can't, as I say, these nozzles can be very weak. We do have to put flexibility in the pipe. A couple of elbows makes a big difference in the loads we actually apply on the vendor. We do have load requirements and no nozzles for all equipment, and that's what we have to comply with. The way around it is we have to put flexibility in the pipe. We just can't go straight from straight to the nozzle. We have to put loops. That's just a different view showing it. This is a different inline vertical pump showing more flexibility here. Here you're looking at an inline horizontal centrifugal type pump. Here you're looking at a steam generator type pump right here. Got different considerations. You've got to bring the steam in, you've got the condensate out, you've got trapped piping to get the condensate out of the steam. It's got the more manifolds and controls to consider during the layout. This is just from a smart plan, just showing some high pressure pumps, some considerations we have for the layout and the flexibility. There was also non-pocket requirements from these plate exchangers. There's another view. When we position pumps, as I say, we always line up the suction and discharge. It's easier for uniform piping, but we'll also, as shown on the picture, we'll try to put the motors towards the pipe rack side. I can't show on this one. This one was different, but I mean I can't show you on this, but I do know that this is 20 feet long. It's really a very large, and we put it. This is the road, main access road right here. So we backed it onto the main access road in this case. But if it's feasible, if it's possible, we have to maintain underneath the pipe rack, keep it clear, 12-foot head height, and we can bring a small little truck, little forklift truck in there. He can pick up the motors and he will pull them back out into the pipe rack and take them away. Usually pumps, they will be maintained, the impellers. We don't tend to take them away from the units, but we will take the motors away. The motors will be picked up and they'll be taken to a maintenance warehouse somewhere and maintained. But the pump itself, unless it's real serious, it will stay in place. So all we have to really basically consider is removal of the motors. But we also have to put the piping on one side. We always have to keep one side clear, just so we can get to the impellers, to the couplings, and review them and maintain them as necessary. One thing that we're getting more and more into on these pipe racks, and that is doing it by modules. And when we have in modules, one thing we do have problems with is bracing. To ship the modules, you know, it may not be for the design for the final, but we do tend to put a lot of braces into the pipe rack. And if we put a brace to support the pipe rack here for shipment, then obviously we can't put we can't pull the motors out because the bracing will hinder access. So one part of our reviews, we'll have to work with our structural group to find out where they're going to brace the modules, brace the pipe rack. Usually a regular pipe rack will be braced at every other column line. So we'll try and position these between those locations. This is just showing options of supporting by springs. Here it's just showing point steel. To take the loads off these nozzles, which are a concern, we will go ahead and we will put springs above them to pull them up. We don't want to put too much load right on top of a nozzle. Sometimes we will pull off it to the side. Certainly on check valves have to be in the horizontal position, preferably on the 6-inch and higher, and we will flat turn them this way to keep them on one side and put a bit of flexibility to take the loads off the nozzles. One other thing we have to consider doing, obviously because of the bearings, the oil mist, which is used to service these rotating locations, there is like a catch area around each of these motors, and we can't, we've got to, if there is a leak or maintenance, we have to catch the oil. And one thing we will do is we'll put like a little drain at the end of each of these pumps, and we'll have to coordinate that with our civil. We can't run it on the ground. We have to run it underneath the ground, and we'll have to coordinate that location with our civil group. But basically, each pump will have its own drain and underground pipe into the main underground system. This is just basically reviewing a lot of the layout requirements, standard requirements. Typical plot for compressors. The arrangement shown is a general plot arrangement for a reciprocating compressor. Individual project requirements will govern. Knockout drums shall be kept close to the machine but spread sufficiently to satisfy requirements, instruments, valving, etc. Provision for future expansion and other requirements shall be provided for only if the client specifies it. Compressors take up a large area. Unless it's specifically said so, we'll just keep it to a minimum and just won't consider future expansion requirements. Building and pipe support columns shall be lined up whenever possible. Sometimes you'll see these compressors inside a building. They can be quite noisy. It also comes with a lot of auxiliary equipment, such as these. You have some knockout pots right here. So you got coolers over here, and I think I just show you on this here. You're looking at a lube oil skid right here. This piping has to be free draining. Again, we will create an area underneath here which is 7'6", so we can actually access underneath here, and that will set the height of this compressor. These compressors are not usually built on structures; they're built on concrete foundations, and basically the reason we do that is because of vibration. If you put it on a steel structure, the whole thing will be shaking. So this is basically a solid mass of concrete with heavy foundation below it. Yeah, and we will always back these onto the road. I mean, a lot of these motors will have to be pulled out this way. They are quite sizable, and we'll always set the compressors on the back side of the road over here. Just like exchanges, if this has to be pulled and maintained, we'll consider breakout flanges here, and we'll position those as... We try to keep these breakout flanges as short as possible, but we also have to be in a position where they can be accessed. Tankage. I'll just do this quickly this is one of our last major piece of equipment that we will consider. I mean, I don't know who's been to some of the facilities, but the tank farm can take up quite an area. I mean, you are looking at access roads all around the facility. They will group the tanks together, whether it's oil or different types of blending type facilities. We have to put, when we group them together, say in this area, we have to design a dike around them. The basic design of a dike, we're looking like this. There's basically, if there is a leakage on the tank, this dike has got to hold the contents of the whatever is in the tank. Pipes that we run through it, if it is run through the dike, we will just coat it and wrap it and just put the dike over top of it. If it's an insulated line, then we will go ahead and put a sleeve on the dike and on the pipe and run it through the dike that way. Now basically it says dike shall be a minimum of 3 feet and a maximum of 6 feet with 1 foot freeboard. Dike enclosures for flammable liquids shall have a net capacity for less than that of the largest tank plus a volume displaced by the tanks of the same enclosure. What that's basically saying is that we'll look at the largest size tank, the volume, and that will determine how much free space. When it says considering the enclosures, we've got to take out the volumes for these 3 tanks, but consider that tank here rupturing, and that will size the area we need to consider for the design of that tank. But again, we've got to consider the spacing between the tanks, and obviously the dike size, and they do get quite sizable based on the volume we have to consider. And that's basically a lot of the considerations we have in the layout for the equipment. A lot of the times we have to coordinate it with other disciplines, but and we are at their mercy if things change. But it's part of our world when we do the initial layout. A lot of our layout is done front end at PFDs rather than P&IDs, and a lot of times we can't get the P&IDs quick enough because they're usually set to the equipment size and process sizes and pump sizes, etc. Our Bibles, our codes and practices. B31.3. That's what we use for the majority of our facilities. The sort of things that we get from B31.3, we get our design criteria from this standard. We get our pressures and design for our piping components come from this B31.3. We have fluid service requirements from the B31.3. Flexibility and supports, all our design comes from B31.3. Material requirements comes from B31.3. Standards of piping components, sizes, fabrication, assembly, erection, inspection, examination, testing. B31.3 is a big part of our criteria when we do our design. You see it on all the documents. We do have B31.4. The difference between B31.3 and B31.4 is that B31.3 is basically for unit design. B31.4 is more for pipeline design. This is for liquids. It's less stringent than B31.3. The basis on that is that obviously B31 units are actually have high maintenance, a lot of equipment that needs to have personnel around over time. B31.4 is for pipelines away from the units and away from personnel, away from buildings, and etc. We will also have B31.8. B31.8 is the same as B31.4 basically for requirements except for ones for gas. And as I said, when we, if the client design requirements do not cover the needs, if Worley Parsons design requirements do not cover the needs, we will fall back to our process industry practice. We actually have, I don't know if you know, on our SharePoint and our website, we do have, I think you have to go to the Houston section to go to the HIS, and we do have a link there to the process industry practices right there, and you can access them from that point. Before you open it up though, you've got to take a note of the password. Because when it opens up, when you try to open something up, it says put in the password. It's there, but you have to make a note of it before you open up the link. When we do our tanking design layouts, NFPA 30. This code basically applies to the storage, handling, and use of flammable and combustible liquids, including lace liquids, and here defined and classified. The purpose of this standard is, for this code, is to provide reasonable requirements for safe storage and handling of flammable and combustible liquids. The sort of things we look for in this standard is a design of and construction of tanks, installation of tanks, testing requirements of tanks, fire prevention and control of our tankage, operation and maintenance of the tanks, piping systems, material piping systems comes from this standard, our piping joints, installation of piping joints, testing, venting piping, and identification of our components basically comes from this standard for tankage. This covers liquids tankage, and NFPA 58, this covers us for our gas tanks. We have to refer to OSHA requirements on a regular basis. Two of our ones that we tend to go through quite a lot is OSHA is 191024 right here, which is for fixed industrial stairs, for our design for access and egress. It's all on the OSHA. There's a website right here, OSHA.gov. All the standards are right there. We go to 1927 for our fixed ladder designs. We have to refer to requirements on this. A lot of it is, whether it's in a refinery, whether it's in a building, we have to consider both options. And if we are in a building, we have to go to our internal building code. We will have to coordinate with our architectural, our civil, our structural group for requirements if we have components inside some layout inside the buildings. Safety, maintenance and operations of a process unit. One thing that doesn't happen, projects don't go forward, projects don't go very far unless we get plot plans approved. It's plot plans showing positions of the equipment, positions of a road, positions of a building, and if we can do a lot of engineering, we can do a lot of design work, unless we coordinate this with our client and get this approved, we don't go anywhere with a project, and we could end up burning lots of engineering hours for no reason. And basically part of our early stage of our projects, we will do a plot plan like this. This is from a smart plan. This is just showing, this is what we'll submit to the client for approval. This is what it really looks like. He'll be looking for access to main equipment such as these condensers, these reactors. What we're looking at here, this is actually a sulfur plant. This is a sulfur plant taken from a CNRL project. What happens after we submit this to the client and he reviews it and comes back with comments or no comments, it allows us to go forward with a project. It starts us to develop a project a little bit further. We'll start developing area classification drawings for electrical drawings, utility distribution plans for maintaining the equipment. We'll start doing equipment location drawings, and that allows us to take a project into the next step into detailed design. But the client will use this for his initial review of access to equipment. He'll look at the roads, he'll make sure we've got the pull on some of this equipment. These are reactors here. They do have catalytic requirements inside them. He'll be looking for pulling his equipment into here to load the catalytic onto there. He won't see this till the model smart plant review, but he'll approve a plot plan before we get to this stage here, and then he'll review, see it again later. In this case here, we got also trenching for the sulfur piping, but again he'll be looking at access. These reactors here, we do need to put catalytic loading through these manways. We will have a large storage area to put these bags that have the catalytic in them. So he'll be looking at this maintenance of this here. He'll be looking at these exchanges or access to these exchanges for us. This is a sulfur pit on the other side. He'll be looking at access to the sulfur pit, which is on this area here. He'll be looking to visit little seal pots underground for low pressuring of the sulfur before it goes into the pit. That's the yes. When we do the PDS, when Bob Carboni, he'll explain. Each colour has a meaning, a requirement. This is a little bit different because when we issue, when we have a smart plant and we issue components, we'll change the colour to white. It lets designers and people know, don't change it because it's been issued to the fabricator. But before it gets to that stage, we do have colours which are blue, could be for waters, green could be for gases, yellows for processed gas, and I think here you're using a sulfur, which is actually for sulfur piping. This is civil structure here. These are actually explosion hatches right here, and this is a manway access. But yeah, we have to consider these explosions inside these pits, and that's what we're looking at right here. But this is what the client gets to review eventually. But we don't want to go too far and do too much work, and that's why we have to get the plot plan approved. and it's part of our focus on getting the layout correct, getting it right. This is just a picture from the site. It's the same as this one here. You can see these reactor drums right here. These are the same ones from the job site right here. This is a tail gas unit. Tail gas unit, also called a Scott unit. This is how it physically looks. This is what we send to the client for approval. He's looking at the major equipment we have over here. He's looking at the roads. He's looking at the incinerator we have right here. These are guide ropes for the toll stack. You can see here you got toll stack here. You can see the guide ropes to support it. You see these operation. This is an operations building. This is a RIB, a remote instrument building. You see the cable trays for the power to the plant coming out of here. We got filters in here. So he doesn't get to see this till later. But through experience, he understands what he's looking at. You can see this building here is. Oops. This building here, which has got the filters in it. He'll just see this outline right here. But he'll be looking at roads coming into here. He'll be looking at access into this filters. You know, for me, he'll look at all these exchanges. He'll be looking for clear access behind on the exchanges. And right here we got a pipe rack which stops, but he's looking for expansion on this project up this way. So this is all part of getting the plot plans approved, so we can proceed with our plant layout. This is a flare area. This is how it physically looks. We got our knockout drums here. We got our flare stacks. In this project right here, we have two flare areas right here. One's actually just in case the other one comes down for maintenance. We want to keep one running. In this case, we got 50% spare requirement. A lot of times we will see multiple flare stacks, and there may be high pressure, low pressure flares. Here you can see the knockout drums. What this line here is showing, it's showing a radiation curve. When the flares go off, there's a radiation or a shine which comes from the flares, and this curve is basically taken from the vendors who give us this location right here. We have to we cannot put certain equipment inside that area. Certain equipment such as the flame front generators, we've located right here. Outside that curve. We have to maintain the drums outside this curve. To go inside this area will take a permit, and for the operators and maintenance. So basically everything is positioned outside here and away from this curve. We have to maintain no pockets on a lot of this system. This knockout drums basically take any liquids out of this line before it goes to the flare tips. And when you go past the refinery, it's where you see the flames shooting out the top here. But we do have we'll create a pocket here, then we'll pump it back to here to take out any liquids before it actually discharges to the atmosphere. And we're showing some of the maintenance roads right here. What you're seeing here is just one unit, but we had 7 or 8 units, and we put them all together, and you don't stop here. With roads carry on. You know, it's just I just shown one model as an example. But when we get into the smart plant, you'll see more of what we do for a client for review. But this is for getting the plot plans approved. That's just a coker unit. This is what the client sees. You see all the coker drums right here. You see some exchanges equipment right here. But in reality, it's a huge structure. You know, this can be 200 feet tall. You got whole stacks of exchanges right here. But I say this is what he'll approve. But that's what it's physically looking at, and that's what he has to understand. Okay. Just take a 5-minute break. Okay.
So if you have 10 pipe in a pipe rack, do you show all the pipe in the plot plant, or just?
No, we don't show anything in the plot plan. Okay. There's no piping in the plot plan. Plot plan is basically for locating equipment. the spacing requirements and access to the equipment requirements.
Pipe rack, right?
We show a pipe rack, but no piping in that. We just show the extent of the pipe rack.
You show the symbol.
So we do. We just show like a little I-beam and just for center lines, and maybe the column.
How about the site plan?
Well, that's the plot plan is a site plan. The site plan, unless you're talking to the civil site plan. But all we need approval on is a plot plan. After that, we will generate equipment location drawings, and eventually we will get into more details when we show the detailed pipe and layout drawings. But to get the plant layout and design approved, we have to get the plot plans approved. And this is more